'Cause even when I'm low, He restores my soul.
Alright folks, this is a pretty standard wiring diagram for a compressor circuit. See if we can kind of zoom in on just this number one compressor right here. As we can tell, this is our number one compressor. What we're going to focus on is just this for now, okay? Because this is basically our control circuit. This we can talk about at another date. But what we're going to follow is 3, which is one side of our control power, and 2. As you can see, we got one side and the other side. So if we follow this down, let's just go here, because this is our compressor. We can talk about time delays at a different time, but for now, just to keep, this is supposed to be for basic understanding. When we move this way in a wiring diagram, as you can see, we have a line, another line, another line. We keep going this way. That's ours in series, okay? When you drive a drop down and it goes underneath, now we're looking at parallel circuits and in series circuits, okay? So right here we have a DPST. Well, if you don't know what that means, you can come down right here, and it's a double pole single throw. So that's our switch. Looks like this. I have it off. I have the compressors off right now because I don't want to have to holler the whole time. So that's our switch. So if you notice, we come down, one side hits our double pole single throw switch. Double pole meaning that whenever you throw the switch, it actually disconnects both sides of power. If we come down here and we trace this, we have it right here, double pole single throw switch. That's the same switch. It's right here. All it's saying is when this thing's in the off position, you have L1 and L2 coming in, it breaks both of them. Okay? Double pole single throw. With one throw of the switch, it breaks both poles, both sides. So we have our control power comes in. Well, this is an open switch. When we close this switch, boom, on that side and this side, it closes. So we come through, we see that we have a parallel circuit. It's connected to the compressor auxiliary contactor, which looks like this. This is our contactor, and this strapped to the side is an auxiliary contactor. You can use this auxiliary contactor to control other things however you want to control them, whether when the contactor is off, this could be in a normally closed state and it could be running our crankcase heater, or you can have it to where when the contactor pulls in, this pulls in and maybe you want to control a head fan or something like that. Anyway, in this case, that's a parallel circuit. We have a normally closed. It goes through the auxiliary contactor, it hits a fuse, and it goes to one side of our crankcase heater. Well, the other side, follow 2 down, the pole's closed. Well, this is a parallel circuit that just branches off and hits this fuse and sends power to the other side of our crankcase heater. Easy peasy. Now, being that this is a parallel circuit, with this, these fuses could blow all day long and it would not affect anything right here. This thing, this portion of it, because it's in series, would continue to run. No problem. That's the thing about a parallel circuit. This is just coming off to the side. If something happens here, well, this can still run and function. Okay, so we close our switch, 15 to 18. That goes from, this is our normally open, TD1. Where is that at? What is a TD right here? I guess you can pretty much guess what it means. Time delay. Okay? So this would be if you were just starting out and say you want to figure out what's wrong with this compressor, why we cannot close our control circuit, our contactor, why won't it pull in? Start right here. Do you have power? I would check this to ground. That's just the way I would do it. If I have 120 volts to ground, then I would go ahead and check from 15 to 18. If we check 15 to 18 and we have 120 volts, that's telling me this is open. So we have to close this, okay? But given that our time delay has timed out and it is closed, we'll check from 15 to 18. Okay, it's closed. Wonderful. Well, we have another little parallel circuit right here. This is just an oil fail relay. We can talk about those, but that's not gonna make our compressor fail. This is just gonna give us a clue if our compressor has failed. That just ignites a light. Basically ignites a light telling you that this has failed, but we want to keep it simple. So check between 15 and 18. Okay, what's next in our series? Oh, we have a Novar output module. It says 01, but that's just standard. You have to look on your legend to know which output compressor 1 is. So we would check from this point to that point. If you have a closed circuit, this is closed and this is closed, well then you know that this and this is not what's causing your compressor not to pull in. So we keep going. Now we get into what? An HPS. Maybe you could guess what that means. I'll give you 5 seconds to figure it out. HPS. It's a safety. Alright, let's figure it out. Come down here if you don't know, if you forget. HPS. High pressure safety switch. Looks a lot like that, because that's what it is. Okay, so we've checked here, we're good. We've checked here, we're good. All right, now we have to check between 1 and 2. This is our open and close right here. 1 and 2. Suppose it's open. Well, there you go. That's what's holding your control circuit from kicking on. All right. Well, suppose it's closed. Well, then you're doing good. All right. Then you know that's not it, because you have a closed circuit. It has not failed. So now we go through. This is in these Carlisles, they have a relay inside the compressor for your overload. So what you could do to where you don't have to pull the pecker head off and check in there, and you'll learn these tricks. I'm making it very simple. What I would have probably done to eliminate all this is I would have checked from 15 to 1, and that would have told me, if all this was closed, that would have told me that this I don't need to worry about no more. Then I would have checked from 1 to L on my low pressure control, and that'll tell me if these are closed. If I have no voltage here, or if it's open, then I would single it down to one of these two things. But suppose we have a good connection and our overload's not open and we have power here, we're running down the line. Okay, now we come to L, now we come to an OPS. Can you figure out what that means? Yep, oil pressure switch. This is an oil pressure switch. With these Carlisles, we use an oil pressure switch on a Copeland. You'll have sometimes you'll have a centronic and a low pressure switch. But with these oil pressure switches, if you're low on pressure, low pressure, then you're going to be low on oil pressure and you're going to fail. So anyway, so now we've determined that this is closed, this is closed, this is closed, this is closed. Now we're going to check between L and M. Oh, it's open. Let's say it's open. Well, there's your problem. Something's going on with your low pressure control. It's not closed. All right, wonderful. So, let's say it's closed. Then you're sending power. Let's say we close it. And we go ahead and fix our low pressure issue, or oil pressure issue, and we reset the control. And let's say it closes. Well, the next thing you're going to get through this series is going to go to one side of your contactor. So you know that from this point to this point, actually all the way to this point, you have a closed circuit. Well, all the way to our contactor. That's one side of our contactor coil. At this point, this is no longer a switch. Okay, this is not a switch. This is a load. This is where L1 ends. What you need now is your other side of your load to hit this coil to energize, okay? That's a basic wiring diagram. If you cannot figure out why your contact is not pulling in, start checking to see what's closed or open. If all this is closed and you got power here and you have power here, 208, and your contactor's still not pulling in, well, you got a bad coil on that contactor, okay? But this is basic. If any one of these things that's running in series, remember, anything that drops off is a parallel circuit that has nothing to do with this. This could go crazy, this could go crazy, this could go crazy, this could do its thing, this could do its thing, and it would not affect anything in series right here. All right? So you want to check from point 15 to 18. All right, I'm good. 4 point. All right, I'm good. 1 to 2. Oh, I got a failure right here. High pressure control. Suppose you check it and it's good. Okay, I checked off this, this, and that. I'm fine. Check, check. Okay, I have power to my contactor. Check both sides, 208. Yep, okay. Well, my contactor's still not pulling in, bad contactor. That's the basic wiring diagram. That's the basic way to troubleshoot. As you get better at these, you'll come out with a way to make it faster. See, what I like to do, I really don't check each point. What I'll do is, I'll come all the way to my high pressure, or I might even start at my low pressure or oil pressure, and I'll check L, and I'll check it straight to ground. If I got 120 volts on L to ground, then I know I've eliminated everything right here. Because before I can get 120 volts from L to ground, this has to close, that has to close, that has to close, this has to be closed. So I'll just do that and eliminate everything right here. Well, suppose I don't have 120 volts to ground right here. Well, then I need to go this way before I could go this way. So you know, you start to learn how to start in different places. But if you're one of those guys that you just want to start from the front and work your way, you will run into the problem. You will run into the problem if you take it step by step. I guarantee it. Something along the line is going to be open, and if nothing is open along the line, then you know you got a bad contactor. You will find a problem if you follow your wiring diagram. Okay, until next time, praise the Lord Jesus Christ. Go in peace.